Welcome to episode 15 of CipherVibe's end-to-end cloud security architecture course. Key and secret management controls the cryptographic material and credentials that make many other cloud protections possible. It separates access to protected data from authority to decrypt, sign, or authenticate. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. It supports encryption, machine identities, pipelines, workloads, data protection, and incident response. The key design question is always who may use, administer, rotate, recover, or export a secret or key, and how that use is recorded. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is separate key administration from key use. Separate the ability to administer key policy, create or delete keys, and manage HSMs from the ability to use keys for encryption, decryption, signing, or secret retrieval. This reduces insider and compromise risk and makes sensitive operations independently reviewable. The second building block is use managed KMS and HSM boundaries. Managed KMS services provide durable controls for many cloud workloads, while HSM-backed options and bring-your-own-key models may support stronger custody or regulatory needs. Evaluate availability, key import, rotation, escrow, regional dependencies, and recovery before choosing a model. The third building block is deliver secrets at runtime. Store credentials, tokens, connection strings, and certificates in a managed secret service, and let applications retrieve only the secrets they need through workload identity. Avoid source code, images, user data stores, build logs, and generic environment exports as secret distribution systems. The fourth building block is rotate and recover deliberately. Automate rotation where integrations allow it. Use dual secret or staged transition patterns to avoid outage, monitor last rotation and use, and rehearse emergency revocation. Include third parties, legacy applications, backups, and break glass procedures in the runbook. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. The reference pattern centralizes keys and secrets in managed custody, lets narrowly scoped workloads use them at runtime, separates administration from use, and proves rotation and revocation through protected audit events. Implement this layer in a sequence that preserves evidence and limits blast radius. First, inventory keys, secrets, owners, consumers, and storage locations second, classify by sensitivity and choose custody model third, separate key administration and usage permissions fourth. Move applications to runtime secret retrieval fifth, automate rotation and test revocation and recovery prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, giving application operators full key administrator rights second, embedding secrets in templates, images, or version control third, deleting or disabling keys without dependency discovery fourth. Treating rotation age as a goal when consumers cannot actually switch safely. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, measure unmanaged secret and long-lived credential reduction second, review key policy changes, use events, and denied actions third, test staged secret rotation with a representative application fourth. Exercise emergency key disablement and controlled recovery test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, write a key and secret lifecycle for a fictional application that uses database credentials, signing keys, and a third-party API token. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that key and secret management becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.